I'm Anil Kumar, and now we are discussing few communication questions from previous test paper. So we'll now discuss about collinear and perpendicular vectors. Here is question here is, if vector A is P28 and vector B is 3Q4, part A is determine P and Q if the vectors are collinear. Part B is determine expressions for P and Q if the vectors are perpendicular. And part C is, are the solutions unique for both the conditions given above? Let us see how to solve such a question. Now the first condition is vectors being collinear. So when I say vectors are collinear, that means they are scalar multiple, right? So we could say if A equals to K times B, then they are collinear, right? So let us solve for this. So we have vector A as P28 equals to K times 3Q4. Now here you can see that how 8 is related with 4. It is 2 times, right? Therefore, I could write K as 2 since we have 4 and 8, right? So we could write this as 2 times 3Q4, right? Now we can actually find the corresponding values of P and K, right? So if you compare 2 times 3 is 6, so we can say P is equals to 6 and Q will be 2 times Q is 2, so Q will be 1, right? So and Q equals to 1, right? So half of this. So that is how you can find collinear vectors. Now let's look into part B, which says determine expression for P and Q if the vectors are perpendicular. Now if the vectors are perpendicular, then what is the condition? That means A dot B is equals to 0. So that is the condition for vectors being perpendicular. So let us solve for this equation. A dot B equals to 0. So we have P28 dot 3Q4, right? So if you multiply, you get 3P plus 2Q plus 32. And since the dot product is equated to 0, let's write it to 0. And now we'll find out an expression for P and Q, right? So we can say 3P is equals to 32 minus 32. Let's take it to the right side. So 32 minus 2Q, and P will be equals to minus 32 minus 2Q divided by 3. So that is a relation between P and Q which will make them perpendicular, correct? Now to find the value of P, what can we do? We can substitute some value of Q, right? And then calculate P. So that is how we can do it. For example, if I substitute Q as 1, in that case it will be 32 minus 2, which will be 34, divided by 3 will give us the value of P, right? So for different values of Q, we can now find different values of P. However, this is the expression which can help you find all possible solutions, right? Now let's look into part C. Part C is, are the solutions unique for both the conditions? So let's consider the condition A. For condition A, we are saying it is unique, right? Since there is only one combination which can make them collinear in this particular case. However, for condition B, it is not unique, right? Since we can have different values of P and Q which can satisfy this particular relation. So part B is not unique, right? Now to divide this by 3, we should have a number so that we get even out numbers, right? So what we could do is we can take a value like if I take it is 32 adds up to 5, right? So if I have 5 plus, if I take this as 2, 5 plus 4 is 9, it will be good, right? For example, if I put Q as equals to 2, in that case P will be equals to minus 32 minus 2 times 2 divided by 3, right? So that is minus 32 minus 4, which is minus 39, minus 32 minus 4 over 3, which is minus 36. So it gives us minus 12 as answer. So that could be one of the solutions, right? So likewise, we can have many more solutions. So it is infinite number of solutions for the second set, right? So that is how we can actually say whether for perpendicular conditions we have unique vector or not, right? Even otherwise, if you have two vectors on this page, for example, right? So any vector which is perpendicular to this page, right, coming out of this page will be perpendicular to both the vectors. So we have many vectors possible which could be perpendicular to both these vectors. That is another way you can communicate the solution for this particular question. I hope that helps. Thank you and all the best.